on the convergence of information technology and operational technology and how utilities can leverage this for smarter, more cost-effective, and reliable operation. This webinar is being recorded, and by participating in it, you're consenting to being part of the webcast. The slides and a recording of the webcast will be available on the NARUC website within a few days. The webcast is being done as part of an award that NARUC received from the Department of Commerce, so we'd like to thank them for their continued support. During the webinar, we'll have everyone on mute except for the presenters in order to manage the background noise. To ask questions, there's a questions function box in the webinar software that's on the right-hand side of your toolbar, so you can enter your questions there. And at the end, we'll have 15 minutes to take questions from the audience. Our first speaker today is John McDonald, who is a global smart grid strategy leader in the North America Global Smart Grid Strategy Group for GE's Energy Connections Grid Solutions business. John has 42 years of experience in the electric utilities transmission and distribution industry. He holds bachelor's and master's degrees in electrical engineering from Purdue University and an MBA from the University of California, Berkeley. John is a fellow of the Institute of Electrical and Electronics Engineers and has received many awards from this institute. John was elected to chair the Smart Grid Interoperability Panel from 2010 to 2014. He teaches smart grid courses at the Georgia Institute of Technology, at GE, and for various Institute of Electrical and Electronics Engineers, Power and Energy Society local chapters. John has published 80 papers and articles and has co-authored 4 books. Next, we will hear from Daniel Ohlendorf, who is a Senior Manager of Electric Emerging Technology Programs at PG&E. The Electric Emerging Technology Program focuses on RD&D program management for the following 3 California programs: California Energy Systems for the 21st Century, the Electric Program Investment Charge, and Smart Grid Pilots. These programs include a variety of projects ranging from cybersecurity research to a technology demonstration of a distributed energy resource management system. Daniel has a master's in systems engineering, an MBA, and a bachelor's in aerospace engineering, all from San Jose State University. We were initially planning to also have Andy Bochman from Idaho National Lab join us to facilitate the Q&A, but he unfortunately couldn't make it today, so that will be handled by NARUC. And with that, I will hand things over to you, John.
Okay, thank you very much, Sharon and Miles. I appreciate the opportunity to go over some material today, and I have to say that this area is an area of a real passion of mine. With work that I've done with electric utilities for 12 years as an international consultant with KEMA Consulting, and then for the past 9 years with GE. So why don't we go to the next slide? And this is just some brief background on myself. Sharon introduced me and highlighted a number of these things. So that'll be in the slides for reference that you can go back to if you want. But, we'll go to the next slide then and get into the material. So one of the things with IT-OT convergence is a fundamental concept that really came up in the late 1990s and early 2000s with the advent of a lot of new microprocessor-based devices from vendors being offered to electric utilities and to the industry. And the fact that we were treating all of the data in these devices as the same. And through a lot of the projects I was doing with utilities as a consultant, I said, no, this isn't the case. Really, we have fundamentally 2 types of data that we need to manage, and we manage these differently. One would be operational data, is what I called it, and the second one is non-operational data. And I wrote an article in IEEE Power and Energy magazine in 2003 that introduced these concepts, which are now industry standards. Okay, and it's very important that all the utilities take this into account when managing data. So operational data is the data that we've normally focused on, which is the data that the operators in the control center need to monitor and control the power system, the grid, what the SCADA system needs, the Supervisory Control and Data Acquisition System in the control center. It's really a time series of data, snapshots of what's happening on the grid, real-time status, performance, loading. It's the fundamental information used by the system operators. And then I give some examples. Status of breakers and switches, current, voltages, loading, both real and reactive power, alarm information. Next slide. In contrast to the operational data, the non-operational data is data items where the primary user is not the system operator, but it's somebody else. And in all the projects I've done with utilities, I find maybe 25 or so business groups throughout the utility that have a need for this non-operational data. And basically, when they have this data, they populate their applications with it, and the end result is they're providing more value to their electric utility organization. Now, many times operators are interested in some of this data we classify non-operational, but in general, it's not needed by the operators. And some examples of this would be circuit breaker contact wear information that is in a relay that's in the substation connected to a circuit breaker, but the protective relay group's not interested in it. The operators aren't interested in it, but obviously the maintenance group is very interested in it. Dissolved gas moisture content in oil, say with a transformer monitoring and diagnostic monitor, or waveforms, digitized waveforms that we want to extract from a protective relay. So what we find is the vendors of these intelligent electronic devices, they contrast themselves competitively with their competitors with the sexiness or with the amount of non-operational data that they put in their microprocessor-based devices. A good example would be a capacitor control device out on a feeder that can provide harmonic information at that point in the feeder. Okay. Next slide. So if we compare the two, operational data, it's typically time sequence data, typically real-time or near real-time information, and we typically transport that or communicate that using standard industry standard protocols, communications protocols, and the most common in North America is Distributed Network Protocol 3, DNP3, which we use from the control center to the field and within the field. Okay. Non-operational data is usually it's points or a data file, where operational data is strictly points. Non-operational data is mostly historical, and then many times for the files we have to use a vendor-specific or proprietary format, the vendor of that microprocessor-based device, to extract the file. Okay. Next slide. So let's look at the Internet of Things. That's what we mean with IoT and new software analytics. Okay. Next slide. So there's what we say is the next productivity revolution in our industry is really the impact of the Internet of Things. And you know, a couple of years ago, the Industrial Internet Consortium was formed with AT&T, IBM, Cisco, GE, all as founding members. There's a lot of work going on in different industry verticals, where energy is just one of the verticals, and a number of test beds that are have been put together. But really what we're talking about here is three things: connecting intelligent machines with big data and analytics, the power of big data, big analytics, and industry physics, and with people at work. So we're connecting people any place, any way, and any time for intelligent operations. And the near future is going to be a much different world, much more connected than it is today. The question is, how can we take advantage of that with the technology that we're developing and the applications, right, that we're thinking about, and what is the business case of this? If we apply the Internet of Things just to the global energy industry or vertical, just a tremendous amount of savings that we calculate at the bottom of this slide. So the question is, how can we take advantage of this? Well, one area would be big data and analytics. Let's go to the next slide, where we're adding more and more sensors in the grid, and particularly one area of focus that we'll talk about here in a little bit is the distribution system. Today in the United States, we have about 48,000 distribution substations, about 15,000 transmission and subtransmission substations. But of the 48,000 distribution substations, only about half of those have any kind of automation installed today. Okay, so there's large areas of unobservability in our distribution system. And if we take that a step further, only about half of those substations with automation installed are using the microprocessor-based devices, the ability for two-way communications. In other words, only half of those have connected the microprocessor-based devices with other devices and with upstream systems, so that half of those are operating standalone, have a tremendous amount of valuable data in them, but it's not being extracted. There's no communications to the device. It's operating. It's a very intelligent device. It's multifunction with two-way communications, but we're operating it as we did with electromechanical relays, which were single function with no communications. So it's really we're not getting the full benefits of the investment, and I want to talk more about that in a little while. But we have a lot of data now. We're adding more and more sensors to the field, and the question is, how can we analyze this data, new analytics that can provide new value propositions to electric utilities? And I really think there's ways we can be much more creative than what we have been, and truly benchmark outside of our industry. Too many times when we benchmark, we only benchmark within our industry. We don't look outside to be more creative. So we've looked at 5 different categories here for new software analytic development. One is insight into the smart meters and the information we get from meters. Second is outage. Third would be reliability of the grid, both health and vegetation management, life cycle analysis, portfolio optimization, renewables, insight, and then last is the customer, the end-use customer. And all of us realized, 8, 9, 10 years ago when smart grid first came up, and we had the Energy Independence and Security Act, ESA 2007, where Title 13 said this is what the U.S. needs to do with smart grid. 2009, the stimulus funds, the ARRA legislation. We said, hey, we have a new stakeholder here that we haven't really dealt with previously, and that's the end-use customer. Things like engaging customers, things like segmenting customers. Not all customers are the same. And 6.5 years ago in the industry, we formed the Smart Grid Consumer Collaborative. We're a founding member, and I'm a founding board member and the board chair of the SGCC. And we have over 100 members, and take all that dues money and focus on research on the consumer side of smart grid. And every year at Distributech, we have a consumer symposium where we issue a State of the Consumer report. And so what we do in that report is, based on the research that was done the previous year, what are the 6 or 7 key themes that need to be taken into account on any end-use consumer side program? So that's a very important new stakeholder that we need to focus on. Next slide. So let's look at the converging, as Sharon said initially, IT, or the information technology part of the utility, and the operations or OT side. So next slide. So this is, in grid modernization, we say IT-OT convergence is critical. And I say, when I work with any utilities on grid modernization, I say, and the Chinese responded with this answer when we asked them early on what their plans for smart grid were. They said, before we think about a smart grid, we need to have a strong grid. Okay, and that's so true and very profound. And what we're talking about is the foundation, two foundational technologies need to be sound and in place before we think about adding anything new, any new intelligence on top. One is the communications infrastructure, because communications is the enabling technology that allows us to automate at all. And second is the IT OT foundation, the IT infrastructure, the ability to seamlessly manage data across the enterprise. So it's extremely important, foundationally important to converge IT and OT. The integration of electrical and information infrastructures and the incorporation of automation and information technologies with our existing electrical network. So comprehensive solutions that we put together with strong business cases for the electric utilities. And I highlight four things here. One is improving utilities' reliability, performance, and productivity. Second is looking at energy efficiencies, but also look at the environment and decreases in carbon emissions. Third is the end-use consumer that we just talked about, empowering consumers to manage their energy use and save money, but without compromising their lifestyle. And then fourth was optimizing renewable energy integration and enabling broader penetration. And that could be at the transmission level, distribution level, or the end-use consumer level. So, you know, the main thing is we want meaningful, measurable, and sustainable benefits to the utility, the consumer, and the economy and the environment. And I'd say one of the best parts about smart grid, the focus of smart grid here in general, is much more attention being paid on the distribution system, which you know, it has been needed for a long time. Next slide. So let me just, in the next two slides, let me just show at a very high level what we mean by IT-OT convergence, data access, and also true holistic company-wide enterprise data management. So on the left here is a situation where we have existing systems like EMS, DMS, Geographic Information System, Outage Management System. We have existing IEDs, or Intelligent Electronic Devices, microprocessor-based devices with two-way communications, and existing repositories. Each siloed group within a utility typically has their own data, their own applications, and their own data marts, or their own data repositories. Unfortunately, though, they work in a siloed way so that when a utility invests in a device, it's the primary owner of that device really doesn't share that information or let other groups in the utility know what the data map of that device is. And so as a consultant, I would find the same value from the same device in a substation in 5 different databases in the utility. So each of those 5 groups was coming across through a firewall, right, into an operational system to extract that same piece of data where we could have done it once in a more cyber secure way, brought it outside the firewalls to the corporate network in an enterprise data mart, and then the access from the different groups could have been outside the firewalls, right, on a corporate network. And that's what we're talking about on the right here, is a holistic approach. Break down the walls between the groups, and when we do have maintenance information in a relay, like the example I gave, a protective relay has maintenance information for the circuit breaker, the I2T information, and the operations counter. Make sure that all the groups that we map the data that has value to the different groups and have an enterprise data requirements matrix holistically across the organization, and an IT infrastructure with a federated data mart with analytics. So we are truly then getting the most value from the investment we've made in all the data sources we have in the enterprise. Next slide. So here's the end result. On the left, we're showing a standard architecture for substation automation with our data concentrator. The DC is kind of the master in the substation. We have master and slave data concentrators, and then a number of microprocessor-based devices, or IEDs. But we have an operational data path that goes up through the SCADA network and over to the control center where we have the EMS, DMS, and possibly the OMS. But we take the non-operational data on a wide area network and go over to the corporate side on the enterprise data mart. And there we have in cyan or the light blue, we have the different types of data, IED operational data, non-operational data. And on the right in green, we show the different users or the different business groups in the utility that now have access to the data in all the data sources of the enterprise, but that data that they feel has value to them to populate their applications. Okay. Next slide. So here's how we realize greater benefits. And bottom line, today, it's true that when a utility invests $5,000, $6,000, $7,000 in a microprocessor-based device, and I can show you this in detail, the utility is realizing no more than maybe 20 to 30% of the potential return or potential benefit of that investment. And it's a number of factors that are not rocket science, but the number of factors to be addressed here to realize those untapped benefits. First is have a workshop within the utility, bring all the utility stakeholders up to the same level of understanding of what we mean by enterprise data management. Then reviewing the data maps of all the devices, systems, and repositories. And that way we identify the data that has value to at least one stakeholder group. This is a mapping process. It's done one time. Then create standard IED data templates. Today, for each microprocessor-based device, every time that device is used in, say, a different substation project, there's a different thinking about which points should be extracted. So if you're a field person in a utility, you go into a substation, you don't know for a particular device what exactly is being extracted because there's typically no standard across projects. Okay, it's different with every project. We need to create standard data templates. Then develop an enterprise data requirements matrix. So we map the data points of value to the stakeholder groups that will use the data. And then review the substation automation architectures to make sure we can extract those points of value, concentrate them at the substation level, and communicate them across the firewall to a platform on a corporate network. Next slide. Okay, let's go on, go to the next slide. So one thing that's very important here is standards. When we converge IT and OT, when we talk about different devices, systems, repositories, these are all from different vendors. But they all have to communicate with each other, and they all have to exchange information with each other. And the only way they can interoperate successfully is compliance to the same set of standards. So as Sharon mentioned, NIST, when NIST got the stimulus money in 2009, they formed a Smart Grid Interoperability Panel. I was fortunate to be elected to that board, and then I chaired the board for over 5 years. And we were responsible for all the Smart Grid standards work for the United States. Well, the first things we did in 2010, on the left here, was develop the Smart Grid Conceptual Reference Model, which many of you have probably seen. It's 7 domains, and it's how those domains then interact with each other. And this is a high-level view on one sheet of paper, let's say, of where Smart Grid ends, where it starts, and where it ends. You know, at GE we say Smart Grid goes from turbine to toaster. Okay, so that's a very wide landscape. What do we mean? You know, what does it look like? So this helped us get our arms around what we mean when we say Smart Grid. Next slide. I think the more challenging thing for us, for the industry too, was providing guidance on which industry standards were the most important. The IEEE identified over 100 standards that touched on Smart Grid, the IEC over 100 standards. But we took all of those and went through them, and you said there's 16 standards that are foundational standards for Smart Grid, and those are the ones we're showing here on the screen. So you only, our you know, advice to the industry is just focus on these 16 for any Smart Grid project that you're doing, and you'll be your interoperability should be successful, and your integration should be successful across different vendors' products, because these are the key standards, whether it's generation, transmission, distribution, or the end-use customer. Next slide. So I'll finish up here with a few slides on cyber. Sharon mentioned that Andy Bochman from Idaho National Labs wasn't able to make it, but I included a little bit of information here, and we can maybe have some Q&A on that if there's some interest. But I'll just go quickly through these. You know, with cybersecurity, there's a failure mode and effects analysis of security. So we look at, you know, we have to define what's the function. We're going to analyze what's the failure mode. You know, in other words, what is the threat? What are the failure causes? In other words, what are the types of attacks? The failure effects and criticality. How serious are the consequences? Understand the solutions. You know, how can we, what are different methods to secure against the attack? And then we need to match the solution to the analysis. Next slide. So when we talk about understanding the threat, you know, what are we protecting against? And here's some examples. And then what are the different types of attacks? Okay, you know, from eavesdropping to spoofing to denial of service, which we see quite a bit, malware. Okay, next slide. So, need to understand the consequences and risks. The analysis of areas of attack. You know, on control, someone could take control of switches, meters, switches in a meter, or switches in substations particularly, could interrupt information flow, could change the configuration of the system, and compromise safety. These are just some examples. Next slide. So we protect, detect, and respond, and need to properly implement. And then these are some things that would be part of our action plan here. Security, intrusion detection, intrusion prevention system, data security. Typically, you know, what's very important today is authentication and multiple levels of authentication, 2-level or even 3-level authentication, and a patch management system. Next slide. So we said, you know, several levels of factors of authentication would be what you know, like a password, what you have, like you have a digital certificate, what you are, or is where we use biometrics like fingerprints and iris recognition, or what you do, which could be like dynamic biometrics like handwriting a signature and voice recognition. So these are some of the more common factors of authentication, and as you have more and more factors of authentication, you have more security. Next slide. So in summary, with cyber, there's NIST and corporate, you know, both NIST or industry requirements as well as utilities' own corporate security requirements. There's functions to protect, which we identify. You need to understand the different threats, the different types of attacks, how likely and serious are the consequences, different methods of security, and then we need to deploy a matching solution. Okay? And I think, Sharon, I think that's my, let's go to the next slide. I think that might be my last one. Oh no, let's see what we have here. Okay, one thing I talked about was every utility really needs to have a holistic smart grid or grid modernization strategy. Break down the silos between the groups and bring all the stakeholders together and say what are the priorities, what's most important for the utility. And what I liked was where the California Public Utility Commission, I think around 2010 or 2011, through an assembly bill, required the 3 IOUs in the state of California to put plans like this together and submit those to the CPUC. And I helped San Diego Gas and Electric put theirs together, and the result is there's, you know, they identified 9 key program areas through 2020, and different time periods of projects that they needed to do to fulfill their objectives. And this truly was an enterprise-wide or company-wide, a holistic plan of everyone working together. Next slide. And that's my last slide. So Sharon, I'll turn it back over to you.
Thank you, John. That was a great overview of the differences between operational and non-operational data, as well as how grid modernization has led to this convergence and how we can derive much more value from data with further IT and OT convergence. I will now turn things over to you, Daniel. Need a moment for
All right. Give you a second to load the slide deck there. So thanks, John, for an excellent presentation. That keys up my presentation really well. My presentation is focused on PG&E's Grid of Things strategy, which is really a big part of what is driving our IT-OT convergence. So if we go to the next slide. So for those that are not familiar with PG&E, we provide energy services for over 16 million people, handle the vast majority of Northern California, as well as areas far down as Bakersfield and San Luis Obispo. We have 5.4 million electric customers and 4.4 million natural gas accounts. Very diverse topography and climate zones. We have several areas that have microclimates, such as within the Bay Area. We are a good-sized company. We are 23,000 employees, regulated investor-owned utility. And one real strong area for us and one really big focus is the continued advancement of distributed energy resources. And right now, over 50% of PG&E's energy supply comes from non-greenhouse gas emitting sources. If we go on to the next slide. So PG&E's vision for the future, we call it the grid of things. For many in the industry, we recognize California as one of the most progressive states, not only in terms of policies and legislation, but also in consumer adoption of things such as PV and EV. This has led to rapid growth of distributed energy resources in the state. Rooftop PV is probably one of the ones we're most familiar with. We have 250,000 rooftop systems in PG&E territory. However, EVs are also growing. We have a potential of around 400,000 in PG&E territory by 2020. We believe very strongly in enabling this customer choice. And it is causing us to really evolve our grid to meet these new customer needs and wants. So therefore, in late 2014, we unveiled our Grid of Things vision. And so our Grid of Things vision is all about integrating new energy devices and technologies with the grid, which allows the technology owners to achieve greater value from energy technology investments. So rooftop solar, EVs, storage, demand response technologies, etc., by virtue of that grid connectivity. With the Grid of Things vision, we see the grid as the platform that enables customer choice, achieves energy policy goals, and provides new products and services. One of the keys to this is interconnectivity. And the way to think about it is, if you take a smartphone on its own, it has a device. It's a device that has certain functions. It has a calculator, has some games, you can watch a movie on it. However, when it's connected, it's more powerful. And access to the information is really key. So long-term, clean energy goals will require more than just DERs. We will need to access large-scale renewable and efficient generation, so transmission and distribution grids will be needed to move energy reliably. Around the industry, there are clear trends that support implementing the Grid of Things. New York, Massachusetts, Hawaii, and several other states are looking towards a future with increasing amounts of distributed energy and are discussing new models for grid operations. Some of these models envision a coordinating entity that optimizes large quantities of multiple types of DERs. We already provide a lot of the grid management functions being discussed in these conversations, and we know that managing more new types of DERs will require evolution on the part of utilities. We want to be a key builder and enabler of this interconnected and integrated platform that will define California's future energy landscape. So how are we building the Grid of Things? If you want to go to the next slide. We're really building it around four main areas. First and foremost is, as I mentioned previously, enabling our customers. Customers want clean energy choices. They want access to more information to empower their choices. And we see more consumers becoming producers or prosumers. So it's a much more complex set of demands. We already have time of use pricing, demand response, DG programs that enable customer choice, but we need to continue to develop new offerings in line with customer demand. However, it's very important that we also understand the value of the new grid services that may be offered in the future, and that the pricing is still fair and equitable to those who are and are not participating. Next, integrating clean DERs. We've made great progress in accommodating DERs. As mentioned earlier, our interconnection times for solar rooftop have dropped significantly because of the volume that we have. We've been able to drop our timelines from 45 days to 3 days or less. However, the next step is really moving beyond just accommodating DERs and actually using DERs to manage cost, reliability, and grid efficiency in this emerging operating environment. This means that DERs go from being not just something connected to our grid, but a resource we actively leverage. For instance, PG&E is teaming up with General Electric to demonstrate a distributed energy resource management system, and with Enphase Energy and Solar City to install and test smart inverters for residential and solar customers. This will give us a good view in a small confined area of what a future grid state could look like and what sort of management systems are going to be required in order to accommodate that. Next, with enhanced decision making, technology, as John mentioned, can provide more data, both faster and more granular. We already have some of this advanced information available to us, but there's a lot of room to use it better and more comprehensively. Building the capability to enhance decision-making involves gathering that data and making it useful with visualization and analysis and incorporating this information into our policies and processes. Next, automate and self-heal. This really helps us deal with the next generation of operational complexities. Automation will be required because a human can't react fast enough or sort through the implications of certain operating conditions fast enough. This is similar to the evolution of automated generation dispatch and digital protection schemes at the transmission level. To implement automated capabilities well, we need to integrate communications networks, control systems, and field devices. Some examples of this for us, one is Flizzr, which is really a self-healing grid technology, but then also we have a VVO pilot that's underway, so a volt-4 optimization pilot. This incorporates sensing, communications, and computing to more tightly control voltage delivered to customers. Objective is to really test to the extent at which VVO can control smart inverters on solar generators as well as energy storage and other grid-connected devices to further improve voltage profiles. Right now, we currently have VVO installed on 14 feeders that have high peak demand and high solar penetration, and we're optimistic about the path forward and its capability. We also are very lucky in the state to have very robust RD&D technology programs made available to us. So we are able to test different solutions without necessarily having to make the commitment of a full production deployment. And this comes through the programs that Sharon mentioned earlier, Customers Energy Solutions for the 21st Century, our electric program investment chart, and our smart grid pilots. So this is allowing us to test things like having energy storage that can interact with the market, some advanced functions of smart inverters, or even our DERMS project that I mentioned previously. Through all of these innovative approaches, we're actively looking at technology to help us enable and manage the growth of DERs and further our development towards the Grid of Things vision. Next slide. So what do we have today? We have a really good foundation in California that we're very lucky to have. We have 82% SCADA penetration. We have 5 million electric smart meters. We have 700 circuits with Flizzr systems. And a good rollout of synchrophaser technology. We're really making technology investments to improve our operations today and lay the foundation for the future. piece of the puzzle is the ability to have system-wide monitoring and control capabilities of the distribution grid. Another significant new technology we've been deploying has been our intelligent switch technology. It helps us to detect a problem, isolate the affected area, and then reroute power around the problem to keep as many customers energized as possible. All this happening in minutes and without human intervention. So next slide. So now that we've laid the foundation, now we're really looking at, okay, what can we do to enable tomorrow? Some of this I've mentioned previously. We have a pilot on volt for optimization. We're also doing work with energy storage, looking how we can bid into the CAISO energy markets. Also testing a lot of work with smart inverters for better control of DERs on the grid. And so through this, we're really starting to build out the foundation through our RD&D programs for that future grid state and for the enablement of the grid of things. Next slide. So bottom line, IT/OT is converging, actively happening in California. We have a multitude of programs as part of that smart grid plan that John mentioned previously. And if you'd actually like to see our smart grid plan, we publish an annual report that you can find at pg&e.com/smartgrid. And with that, I think we'll open it up to questions.
Thank you, Daniel, for that overview of how convergence has been happening in California and for sharing more on what PG&E's smart grid plan entails. So if you have questions, we have about 15 minutes left, or a little more than that, so please type your questions into that questions box on your toolbar on the right side, and I'll read those aloud to the presenters. Well, one question I have right now is a security-related one. The values of efficiency and security seem to be more opposed. Is that how it looks from your vantage point?
I can take a first crack at that, Sharon. From a manufacturer point of view, there are trade-offs, and I think that's what we mean by efficiency. There's trade-offs between how much cybersecurity functionality we implement and the impact that may have on performance and price of the product or the technology. So I'll give you an example. With communications equipment, when we implemented digital certificates, initially there was a 200 millisecond additional latency associated with that additional overhead that was in the technology. So there is a trade-off between efficiency and functionality. What we did was we went back into the code and we were able to optimize the code to a greater extent, pretty much eliminate that 200 millisecond of latency. But it's something that really has to be considered. Another aspect we do when we add cybersecurity functionality, we look at the architecture and we say, okay, does this functionality need to be added at the device level, or maybe one level up, like the data concentrator level, or maybe one level up the system level? And we can make trade-offs there and choices there that minimize the impact to the customer, to the electric utility, with respect to price and performance.
Okay, thank you. Daniel, do you have a perspective you'd like to share on that?
Yeah, I agree with John. I think there's definitely trade-offs that need to be considered. And John's last point that he touched on is one of the most critical. Customer affordability is really, really critical. We have customers in some of our warmer territories that end up with very high bills in the summer due to AC loads and other things of that nature. And so as we're looking at kind of continuing to progress the grid forward, which we need to do, we have to consistently balance that with keeping rates affordable for our customers.
Okay. Those are some great points. Thank you. Another question we have is, Is it true or false that Convergence makes it easier to attack ICS, Industrial Control System?
I'll take a first crack at that. I mean, on the surface, it's true that we've gone in the industry from serial communications and proprietary communication protocols to industry standard protocols and network communications. There's a lot of benefits to that, but it also has left us more vulnerable from a security point of view, because if a hacker gets into the network, you have access to a much wider reach, and our communication protocols today, like DNP3, are published, so you know the bit patterns, for instance, to control a device. So by bringing IT and OT together, you're trying to seamlessly bring together an infrastructure which has a lot of benefits, as Daniel and I talked about in the webinar. I think what we have to think about the cybersecurity, key points and the things I talked about at the end of my portion of the webinar, and that identifying what the vulnerabilities are and making sure that we're protected. I think the one I'll finish with one key point, that cybersecurity expertise on the IT side, which is much more common today, is not what's needed on the OT side. Cybersecurity expertise on the OT side is harder to find, and when you're talking about real-time operational systems, there's a lot of new aspects with respect to cybersecurity and vulnerabilities when we get into OT. So if I would look from a utility point of view, I would look at experts on the OT side, but I also wouldn't assume that my IT experts could truly do a good job on the OT side. I'd look for folks that have cyber expertise, particularly on the OT side with real-time operational systems. And then I put a team together of OT and IT cybersecurity folks, and then I feel more comfortable with protection then from a cyber point of view of my seamless IT-OT converged infrastructure.
Thank you. Daniel, did you want to comment on that?
Yeah, just to add a little bit to it, I think how we're looking at cyber also needs to continue to evolve. One of the programs I mentioned, CES 21, that program is heavily focused on kind of the next generation cyber. And what we mean by that is really going to the place where instead of us being reactive about potential cyber problems, we end up being proactive. And so we're looking at ways to enable machine-to-machine automated threat response. And that will really help us better protect the grid in the future state. But this, very early research that people are still figuring out. And so not only are we bringing together our IT and OT teams inside of the utility, but we're also partnering with Lawrence Livermore National Labs and Idaho National Labs to help bring in the lab environment to really kind of start figuring out this problem.
Thank you. The next question is, the Internet of Things is positioned, among other things, as an IT-OT silo breaker. Is it also an organizational silo breaker?
I would say if it's done correctly, it should be. And to me, with Internet of Things or with anything new that we're thinking about adding to an existing electric utility, suite of applications or technology. And Daniel emphasizes too with this slide, there's a foundation that needs to be in place first. And that foundation needs to be sound, solid, robust, and up to date in functionality. So if Internet of Things to me is just another new application, and we need to make sure before we do anything with implementation, whether it's volt-var optimization like Daniel said, or fault detection, isolation, restoration, or Internet of Things, or whatever. Let's have a sound communications infrastructure, have a sound converged IT/OT infrastructure, and then we're best positioned. And by sound, I mean breaking down the silos and have a true holistic approach where, like Daniel and PG&E, like San Diego Gas and Electric, like Southern Cal Edison did with their holistic plans, they looked at what their objectives organization-wide, you know, rather than group by group. So yes, to me, a first step with anything we're talking about here is having a holistic approach and having all groups work together.
Yeah, I 100% agree with that, John. One of the things that we've seen more and more over the course of the last 10 years is really just a breaking down of silos within an organization such as PG&E. You know, all too often there's going to be very refined perspectives that we're looking at things in different ways, but the move towards the grid of things really causes those silos to break down and people to start working together. So for instance, when I was talking about our DERMS program, there's multiple different perspectives there. There is, you know, a policy and customer focus that's looking at customer acquisition for further DER growth. There is a grid control standpoint that is looking at, okay, how do we manage all these resources once they come online? And then there's also a, you know, energy procurement standpoint, which is looking at, okay, how do we interact with the market? So the growth towards the grid of things is absolutely breaking down those walls.
Great, thank you. The next question we have is for Daniel. What aspect of the grid of things has a visible and understandable value proposition today for utilities?
So I think, you know, there's multiple pieces of it. It really comes back to kind of those 4 competencies that we're looking to grow. You know, being a regulated, decoupled utility, we have the ability to focus on, you know, driving key policies in California, as well as have a heavy focus on customer satisfaction, enabling our customers to continue to have customer choice. So a lot of those benefits we have the capability to move towards based on the regulatory structure that we have here. There's also, you know, models that could potentially come in play in the long run. For instance, you know, with more EV growth, there's going to need to be a real strong look at electrification, how we approach that. So I think there's a lot of opportunities in the changing grid landscape that we're just starting to figure out.
Great, thank you. The next question is for John. What role are machine learning and predictive analytics playing in creating a value case for the grid of things?
Well, I think machine learning and predictive analytics are that Daniel introduced, and I'll expand on, and that was the concept of being proactive rather than reactive. You know, it's very important, and we've done a lot of this with tremendous benefits for electric utilities. Is you know, try to be as proactive as we can. In other words, anticipate the future, collect the data, have the analytics, and predict and position, as opposed to just be in a reactive mode. You know, I think all of us would agree we'd rather be in a proactive mode with our lives and with the work we do than to be reacting to what others are deciding all the time. So predictive analytics help us, you know, use all the data we have today and the learning and predict and then position ourselves optimally for what we feel the future will hold. In addition to that, we get into things like self-healing, which Daniel talked about, which is something which has both technology and cultural implications. Technology is the easiest part. Culturally, we need to accept the fact that we're moving from a centralized to a distributed architecture. which is more hybrid architecture for the future, a combination of centralized and distributed. And second is on a distribution system, once we test the logic, to accept the fact that we can close the loop on the logic, which helps us tremendously with SAIDI and safety or system reliability. All of this is more predictive, right? And it's more proactive than it is reactive. And so Internet of Things and what we talked about with the concepts there align with this extremely well.
Thank you. The next question, it relates to something we saw on one of John's slides relating to data mart. Can you explain what a data mart is, or a little bit more about it, and how it can serve as a decision support tool? And then also, are there companies that are currently using them?
Yeah, in the work I've done in this area for over 15 years, I laid out the steps, and the concepts to apply. And by the way, I've written a couple articles in major trade publications I'd be happy to share with those that want additional information. But you're right in that the platform is the core of this. And for many, many years, I wasn't finding the platform that had the functionality that we needed. For instance, we need to be able to support both operational and non-operational data. Operational data is easy. That's what OSIsoft Pi, InSteps, eDNA, the typical SCADA historians can support. It's the non-operational data that's both point and file, like sequence of events reports, digitized waveforms, and so just recently I've found a company that has a data enterprise platform that meets the functional requirements I've been looking for, and it's a company called Trigma, T-A-R-I-G-M-A, Trigma Corporation in Columbus, Ohio, and a product called the Grid Enterprise Manager, or GEM, G-E-M. So with the work we're doing with utilities now, applying the concepts, but now I feel like I have the functionality I need in the core platform to pull it all together. And what else is included in there, not just support of operational and non-operational data, but also to support codes of conduct, right? Because of the 25 or so business groups, the operators, we have to partition that data mart because not everyone can have access to all the data there, right, through things like codes of conduct, security, and other attributes. So, there's a number of things we look for functionality-wise in a platform, and I feel like for the first time, I've got the platform that meets the functional requirements I've been looking for.
Okay, thank you very much. We have gone through all the questions from the audience, so if there aren't any others, we can go ahead and conclude the webinar a couple minutes early. Just want to thank John and Daniel again for a very informative and insightful discussion of how and why this convergence has been taking place and what the benefits and potential trade-offs various stakeholders are. So thank you very much, and I hope everyone has a really great afternoon.